A warped or deformed cylinder head occurs when the cylinder head, the vital engine component that seals the combustion chambers and contains valves, coolant passages and oil channels, loses its original flatness and geometry. This distortion is most often caused by overheating, which is the single most common reason cylinder heads warp. Because aluminum expands more rapidly than cast iron, aluminum heads are especially prone to distortion when an engine overheats severely or undergoes repeated thermal cycling. Poor cooling system maintenance, such as low coolant levels, clogged radiators, failed thermostats, or malfunctioning water pumps, can create localized hotspots that contribute to head warping. Improper torque application during cylinder head installation is another common cause, as uneven or incorrect torque stresses the metal and can distort it over time. Other contributing factors include detonation or pre-ignition, which generate excessive combustion chamber pressures and heat, and simple age-related fatigue, where repeated heating and cooling cycles gradually degrade the metal's stability. When a cylinder head becomes warped, it produces a very distinct set of symptoms. Loss of compression is one of the primary signs because the combustion chamber is no longer sealed properly. Warping prevents the head gasket from sealing evenly, allowing compression to leak past the gasket. Coolant leakage, whether external or internal, is another common issue, since misaligned coolant passages permit coolant to seep externally down the block or into the cylinders. Oil contamination, often recognized as a milky discoloration on the dipstick or filler cap, happens when coolant and oil mix through breached passages. White exhaust smoke is a telltale sign because coolant entering the combustion chamber burns as steam, often with a sweet smell. Rough idling and misfires also occur because uneven compression across cylinders leads to unstable combustion. The engine may overheat further since the initial warpage causes coolant leakage and steam pockets that reduce cooling efficiency. In many modern vehicles, the check engine light is triggered when the ECU detects repeated misfires, abnormal O2 sensor readings, or reduced efficiency caused by combustion disruption. Each of these symptoms has a clear mechanical explanation. Coolant passages deform when the head warps, which allows coolant to leak into cylinders or externally. The head gasket loses its ability to seal, letting combustion gases escape into the cooling system or atmosphere. Uneven compression directly results from the deformed mating surface, which no longer holds pressure consistently across cylinders. Oil and coolant can mix because formerly separate channels between these fluids open into one another under the stress of warpage. The overheating becomes a vicious cycle as coolant leaks or vapor pockets impair heat transfer, which raises temperatures further and worsens the original distortion. Diagnosing a warped cylinder head requires a systematic approach. The first step is a visual inspection, looking for signs such as oil contamination in the coolant reservoir, a milky appearance on the dipstick, external coolant leaks along the head-to-block seam, or persistent white smoke from the exhaust. Once basic observations are made, the next step is the straightedge and feeler gauge test. With the head removed, a precision straightedge is placed across the head surface in multiple orientations, lengthwise, crosswise, and diagonally, and feeler gauges are inserted to measure warpage. Acceptable tolerances are typically around 0.02 to 0.04 inch, 0.5 to 0.10 mm, though this varies by manufacturer. Compression testing should follow, since uneven or low compression across multiple adjacent cylinders strongly indicates sealing failure. A leak-down test can pinpoint exactly where compression is escaping, whether into the cooling system, the crankcase, or externally. A cooling system pressure test is another valuable tool, where the system is pressurized to observe whether coolant leaks externally or internally into combustion chambers. In addition, a chemical block test, sometimes called a combustion leak test, can detect exhaust gases in the coolant, which is a strong indicator of combustion to coolant leakage. Because other engine problems can mimic these symptoms, differentiation is critical. A blown head gasket, for instance, produces very similar symptoms such as white smoke, coolant loss, and oil contamination. However, while a blown gasket may occur independently, it is often worsened or even caused by head warpage. A cracked engine block can also lead to coolant oil mixing, overheating, and misfires, but typically reveals itself with external cracks, persistent leaks, or ongoing issues even after the head is replaced. Overheating caused by a faulty thermostat or water pump does not usually cause oil-coolant mixing or compression loss, so when those symptoms are absent, the cooling system itself may be at fault. Similarly, radiator or cooling fan issues usually cause overheating only, without the additional sealing and combustion-related problems that warped heads create. Ignoring a warped cylinder head is risky and often catastrophic. Progressive engine damage occurs as overheating continues, harming pistons, valves, and catalytic converters. Severe warpage can render a head completely unrecoverable, leading to full engine replacement. Safety risks include sudden power loss, excessive steam emissions, and breakdowns on the road. From a financial standpoint, costs escalate quickly. A cylinder head that might have been repairable with resurfacing for a few $100s can easily turn into a multi-thousand-dollar engine replacement if ignored. Driving with a warped head nearly always accelerates damage to other engine systems, so what begins as a manageable problem can become a total engine failure. Repair solutions depend on the extent of the warpage. If distortion is within the manufacturer's specified tolerance, the head can usually be resurfaced or machined flat at a machine shop. This precision milling, which typically costs between $150 and $500 depending on complexity, allows a new gasket to seal properly. If the head is cracked or the warpage exceeds tolerance, replacement is the only option. New or OEM replacement heads can range from $800 to $2,500 or more, and because the labor is intensive, total job costs often exceed $1,500 to $4,000. In cases where both the block and head are compromised, complete engine replacement or rebuilding may be the only viable path, with costs ranging anywhere from $3,000 to $7,000 or more. Whatever path is chosen, it is absolutely essential to address the root cause of the failure, whether it was a failed cooling system component, improper torque procedure, or detonation issue, before reinstalling a repaired or replacement head. Ultimately, the key takeaway is that a warped cylinder head disrupts the most fundamental functions of an engine: sealing compression, separating coolant and oil circuits, and maintaining efficient combustion. Diagnosing the problem requires a structured approach that combines observation, measurement, and testing. Early detection offers the best chance of resurfacing and gasket replacement, but neglecting the issue almost always leads to irreversible engine failure.